Okay, so now we'll just go over the principles of operation of an electrochemical cell. And once you understand this, you can just apply the same concept like on every electrochemical cell. So it's pretty trivial. So what is an electrochemical cell? An electrochemical cell is composed of a, a driving voltage that's provided by the battery or a cell, right? It contains electrodes, and then it contains this, it also is composed of this container which is filled with a solution, right? And the solution is usually a conducting solution, right? Which has mobile ions. So this is a typical electrochemical cell, right? And you can see in this electrochemical cell, this is a very complex electrochemical cell actually. Let's draw our own electrochemical cell. So we have like a battery. So here, this is the negative terminal, and this is the positive terminal. And at the negative terminal, what is the negatively charged electrode called? What is the negative electrode? Arisha.
Cathode.
Cathode. Okay. So, uh, wait. So a negative electrode जो है, it is the cathode, and the positive electrode जो होता है, it is the anode, right? So we were looking at the electrochemical cell, and the negative electrode was the cathode, right? So positive electrode is the anode. So yeah. Now we have this electrochemical cell. This is a container, and this container is actually is filled with a conducting solution, right? So for the electrolysis to occur, this solution must contain mobile ions. सही हो गया? अच्छा, अब इसमें ये होता है कि let's take a very simple example. Let's take water, ठीक है? And we have distilled water. So distilled water में is water conducting, Aslan? Does water conduct electricity?
Yes.
Okay, you are right if you're using tap water. Okay, if you're using tap water, that will conduct electricity. So if you just put a metal, a live wire into water, and then you submerge your hand in the same container, you will probably electrocute yourself, right? Because that water is highly conductive, tap water. And that's because tap water contains many dissolved ions, right? But distilled water, on the other hand, right, pure H2O is what? It's a covalent compound or an ionic compound? H2O, Arisha.
What were you saying?
Is pure H2O a covalent compound or an ionic compound?
It's a cool. No, it's an
Yeah.
ionic compound.
No, it's covalent.
Maybe.
Okay. It's covalent. So pure H2O is covalent compound, right? And when you have pure distilled water, so water doesn't dissociate into ions, right? H plus and O2 negative. Does nothing like that. So yeah. So pure water is not conductive. Okay. If you submerge your hand in pure water, and if you put a live wire inside that pure water, and if you submerge your hand, you won't get electrocuted. So you can just watch videos on YouTube, people doing that, and they don't really get electrocuted. That's because there are no free ions in pure water. But if what if I just add a teaspoon of sodium chloride in this pure water? Because I add sodium chloride. Now sodium chloride is ionic or is it covalent? Aslan.
Ionic.
It's ionic compound. Exactly. So as soon as I add solid sodium chloride into pure water, so what will happen? Sodium and chloride will dissociate, right, into Na positive and Cl negative ions. Okay, so there will be a lot of Na positive ions and the Cl negative ions. सही हो गया? So there will be a lot of ions. Now, what will happen at now if we have a voltage, right? So we have a lot of submerged ions, and this solution is now conductive. So yeah, this is a brine solution, and we have a lot of ions. So we have the negatively charged cathode and we have a positively charged anode. Okay. What will happen? So the chloride ions will be attracted to the positively charged anode. The sodium ions will be attracted to the negatively charged cathode, right? So what will happen? So chloride, let's just look at chloride. So chloride right here will actually, what will happen? So electrons will be stripped from chloride, right? It will be taken away, they will be taken away from chloride, and chloride will be reduced, sorry, it will be oxidized to form chlorine gas. So yeah, form chlorine gas, and two electrons will also be released. So yeah, and since this equation is not balanced, so we'll just add a 2 here. So yes, this is the reaction which will be occurring at the anode, right? So it is an oxidation reaction. Remember anox, right? Now, since chloride lost its electrons, so these electrons, what will happen? These electrons will travel all the way. Let's just use a different color. These electrons will travel all the way from the anode to the battery, and then it will travel all the way to the cathode. What will happen at the cathode? Sodium, either concept sodium. Sodium was attracted to the cathode, right? The negatively charged terminal. So at the cathode, sodium will gain those electrons which were lost by chloride. They all had a journey, traveled from the wires to the battery and all the way on to the other side. And sodium will gain those electrons. See, and after gaining those two electrons, what will happen to sodium? Sodium will be reduced or oxidized. So sodium will be reduced, obviously. So you'll see that on the cathode, since sodium is being reduced, it is forming the solid sodium, right? It is being converted into the solid sodium form. So at the cathode, you'll see a whitish deposit on the cathode. Okay? Over time, you'll see as the reaction goes on, as the electrolytic reaction goes on. So you'll see a whitish deposit on the cathode. That is basically solid sodium depositing, the reduced sodium ions turning into the solid sodium, right? And on the anode side, what will happen is since you're forming a gas, you'll see bubbles on the anode side, right? So there will be a lot of bubbles on the anode side because chloride ions are being oxidized to form chlorine gas. Okay? So this is the basic principle or the basic working of an electrochemical cell, right? And if you understand this, you'll be able to understand electrolysis throughout. You can just apply this concept on everything and you'll be good to go. So yeah, that ends our lecture for today.